Good everyone, my name is Dominick Lariosa of BSCS C2019, and we will talk about for today's video is the anatomy of a large-scale hypertextual web search engine by Sergey Brin and Lawrence Page. And this will be the reporter for today's video, which is Lariosa Dominick, Valenzuela Nathaniel, Boco Marc, and De Torres Jerreme. And this will be the topics that we will discuss for today's video, which the first of all is the introduction of the hypertextual web search engine, the design goals, the system features, the system anatomy, and the conclusion. So the first one that we will discuss is the introduction of the hypertextual web search engine. So, introduction. In this paper, the researcher present Google a prototype of a large-scale search engine which makes heavy use of the structure present in the hypertext. Google is designed to crawl and index the web efficiently and produce much more satisfying search results than existing systems. Index tends to 100 millions and answers tens of millions. The search engine's index tends to hundreds of millions of web pages involving a comparable number of distinct terms. They answer tens of millions of queries every day. The web creates new challenges for information retrieval. The amount of information on the web is growing rapidly, as well as the number of the new users and experience in art of the web research. People are likely to surf the web using its link graph, often starting with high quality human maintained indices such as Yahoo, of Google, and DuckDuckGo, with other search engines also. Web search engines scaling up to the year of 1994 into the year of 2000. Search engine technology has had to scale dramatically to keep up with the growth of the web. In 1994, one of the first web search engines, the World Wide Web worm, which is the www, had an index of 110,000 web pages and web accessible documents. As of November of the year 1997, the top search engines claim to index from 2 million web crawlers to 100 million web documents from Search Engine Watch. And it is foreseeable that by the year of 2000, a comprehensive index of the web will contain over a billion documents. At the same time, the number of queries search engines handles had grown incredibly too. Let's scale up the web. Scaling with the web. Creating a search engine with scales even for today's web presents many challenges. Fast crawling technology is needed to gather the web documents and keep them up to date. Storage space must be used efficiently to store indices and optionally the documents themselves. The indexing system must process hundreds of gigabytes of data efficiently. Queries must be handled quickly at the rate of hundreds to thousands per second. These tasks are becoming increasingly difficult as the web grows. However, hardware performance and cost have improved dramatically to partially offset the difficulty. So the next discussion will be the design goals, and it will be discussed by Mr. Marc Boco.
Good day, everyone. My name is Marc Boco, and I will discuss about the design goals. First design goal is improve search quality. The researcher's main goal is to improve the quality of web search engines. In 1994, some people believe that a complete search index will make it possible to find anything easily. According to Beast of the Web 1994 navigators, the base navigation service should make it easy to find almost anything on the web once all the data is entered. However, the web of 1997 is quite different. Anyone who has used a search engine recently can readily testify the completeness of the index is not the only factor in the quality of search results. Junk results often wash out any results that a user is interested in. Next design goal is academic search engine research. Aside from tremendous growth, the web has also become increasingly commercial over time. In 1993, 1.5% of web servers were on .com domains. This number grew to over 60% in 1997. At the same time, search engines have migrated from academic domain to the commercial. Up until now, most search engine development has gone on at companies with little publication of technical details. Next will be discussed is the system features.
Hi, my name is Nathaniel Valenzuela. Here I will discuss the system feature of web search engine, and the Google search engine has two important features. First, it make use of the link structure of web to calculate quality ranking of each page. This rank called page rank. Second is a Google utilized link to improve search result. In page rank bringing order to the web. Page rank bringing order to the web. The citation link graph of the web is an important resource that has largely gone unused in existing web search engine. Google have created a map containing as many as 580 millions of these hyperlinks, a significant sample of the total. This map allows rapid calculation of a web page using a page rank, an objective measure at citation important that correspond well with people's subjective idea of important. And page rank is an excellent way to prioritize the result of web keyword search. Anchor text. The text of link is treated in a special way in our search engine. Most search engines associate the text of a link with the page that link is on. In addition, we associate it with the page the link points to. This is a several advantage. First, Anchor often provide more accurate description of web page than the page themselves. The second is Anchor may exist for documents which cannot be indexed by a text-based search engine such as image, program, and database. And the next reporter is Jerreme De Torres.
Hi, I'm Jerreme De Torres and I will be discussing system anatomy. First is the anchor text. In Google, the web crawling, downloading of web page is done by several distributed crawlers. There is a URL server that sends list of URLs to be fetched to the crawlers. The web pages that are fetched and then sent to the store server then compresses and stores the web pages into a repository. Every web page has an associated ID number called doc ID, which is assigned whenever a new URL is parsed out of a web pages. Next is crawling the web. In order to scale hundreds of millions of web pages, Google has a fast distributed crawling system. A single URL servers list of URLs to a number of crawlers. Both the URL server and the crawlers are implemented in Python. Each crawler keeps roughly 300 connections open at once. This is necessary to retrieve web pages at a fast enough pace. At peak speeds, the system can crawl over 100 web pages per second using 4 crawlers. Each crawler maintains its own DNS, so it does not need to do a DNS lookup before crawling each document. And last, searching. The goal of searching is to provide a quality search results efficiently. Many of the large commercial search engines seem to have made great progress in terms of efficiency. Therefore, Google have focused more on quality of search in this research. Although the solutions are scalable to commercial volumes with a bit more effort. And lastly is the conclusion to be discussed by Jan Dominic.
Hi again. And for the conclusion of our topic is the researcher find out that Google is designed to be a scalable search engine. The primary goal is to provide high quality search results over a rapidly growing World Wide Web. Google employs a number of techniques to improve search quality, including PageRank, anchor text, and the proximity information. And furthermore, Google is a complete architecture for gathering web pages, indexing them, and performing search queries over them. And this will be the references of our topic. And that's all. Thank you for listening, guys, and stay tuned. Thank you.